Well, I am very excited about the three projects Paul, Luke, and Michael have spoken so far. I'm going to talk about a fourth CNCF project, which is the SPIFFE project. It is a incubation level project. My name is Andres Vega, by the way. I work at VMware as product manager for product security within the VMware Tanzu portfolio. And I am also one of the technical leaders for the CNCF Technical Advisory Group for Security. If anything of what I'm about to present has any reaction on you, you'd like to learn more, would like to have a discussion, feel free to reach out over Twitter. I am invariantly over there. So the problem that SPIFFE focuses on is one fundamentally of identity. It does have many applications beyond that, but fundamentally what it tries to solve is this crab just crawled on my infrastructure. Should I trust it? It looks cute. It looks a lot like the confidential computing logo, but how do I know for certain? How do I give this a production identity that I can enable access control around? So whether it's crabs or it's turtles, enabling access control typically requires a secret, be it an API key or a password, and that password needs to be in turn protected. You can encrypt it, but once you've encrypted it and checked it in somewhere, like you need to worry about the decryption key. And that other decryption key needs to be securely stored. You need to be able to unseal it, and it's turtles all the way down. It's infinite regression. So how do we move towards proof of possession and handling of this material to unlock that secret zero problem that we can use for secure introduction? Now, you're going to often hear about SPIFFE and Spire together. SPIFFE is really a spec. Think of it as a cert distribution protocol, and the specs for the APIs and documents that are in turn used to prove the identities, how these identities get exchanged, how can they use to cross-authenticate one service to another. And then Spire is the software implementation of those specifications so that you can make use of it in practice. The set of SPIFFE specs, there are a couple more, but these are the core. There is the notion of an identity. Then that identity gets embedded into a document. There's two flavors for that document, and we're going to look into those in more detail. And then there's the interface to do any operation for these identities. So starting upon the first, the SPIFFE ID looks a whole lot like this, and the schema of it, the syntax is really one of a trust domain, which models the trust boundary against a top-level root of trust. It can represent your development cluster. It can represent your production cluster. It can represent an environment. There's a lot of flexibility on how to model this. And that is followed by the name of the workload identifier that will uniquely identify any running instance of this particular service. That identity, as mentioned previously, gets embedded into what we call a NSVID, a SPIFFE verifiable identity document. This document, by definition, is short-lived. A key piece here is we're moving away from hard-coded, long-lived embedded credentials into this short-lived, you define the TTL, dynamically rotated, cryptographically signed, programmatically driven, and the system is handling the rotation, the issuance and the rotations of these. So every single identity will represent the carrier, the bearer of it. Once again, there's support for X509s and JSON Web Tokens. X509s are suitable wherever you may want to do MTLS. There might be environments where that doesn't work, and then you might want to consider JOTS in those places. There's some considerations for one over the other that I've captured here in the slide. Then we look at the workload API. It is a dead simple local API. It's typically exposed over a Unix domain socket. A service, once it gets instantiated without no a priori knowledge, is going to call this API and ask, who am I? The workload API in exchange will run a set of attestation checks. It's going to, off the PID of the calling process, do kernel level introspection. If it's running on Kubernetes, it's going to interrogate Kubernetes to learn what Kubernetes knows about it. If it did in fact schedule this workload. If it's running in AWS, it's going to query the AWS instance metadata API and look for what security group, what availability zone, what VPC. If these things match the policy, it will only then sign the credential and issue it to the workload. There's opportunities here that I'll talk in more detail of. There's the testers for hardware level roots of trust that I'll explore in more detail. So let's get into Spire and what are the components beyond what's captured in the SPIFFE spec that make this consumable for developers and for organizations. There is the Spire server, which is a component that manages the registration of all SPIFFE IDs. And it keeps track of which of these identity documents have in turn been issued. It supports different pluggable backends. We're gonna look a little bit at the plugin interface. All the identity, this is your CA. Think of it as the CA of your PKI. All the SVITs in a given trust domain are going to be signed by the Spire server or cluster of Spire servers if you're running an HA. Then we have the Spire agent, whose role is to serve that workload API to clusters. If you're running on a VM or you're running in a Kubernetes node, this is what's going to expose that API to a process or to a container. The architecture of Spire is modular, is extensible. There are a number of plugins that exist. There are plugins for plugging in existing upstream certificate authorities. There are data store plugins for different pluggable backends. There's a key manager, whether you want your keys stored in memory or you want those on disk. There are plugins for different attesters at a hardware level, different attesters for different platforms. There have been attesters written for TPM, great work by the folks over at Bloomberg and Voxbot who contributed that to the project. But once you've bootstrapped a Spire deployment and you want to make sense of it, here's the key flows that occur. There's two stages of attestation. The first one being the node attester. So you have a node, you've deployed the Spire agent. We want to attest the integrity of that machine and how the trustworthiness of that machine. So let's say this is running in AWS. This agent comes up. We want to know from the AWS instance metadata API, is this a machine we can trust? Is it not a rogue machine? So we're gonna get the identity document. We're gonna verify that identity document against the instance metadata API. If we're able to resolve that, we're gonna then issue it an identity and bring it onto the trust domain. Now, the moment a workload, this is the second stage, the moment a workload comes up for the first time, it calls the workload API, and the workload API and the agent will trigger introspection to the kernel. It's going to look off the PID, what other metadata is available, what is GID, etc. Kubernetes, what namespace, what service account. from Docker, what are the labels? What are the environmental variables for this container? What is the image? Here you can do things around, well, if we're going to do binary authorization, has this binary been signed? So that is it in a nutshell. I hope this elicits consideration for, well, what's the intersection with confidential computing? And there have been folks in the community looking hard at the problem and have produced a set of proof of concepts for, one, running Spire agents within SGX. The advantage of this is the agent integrity, particularly key manager plugins, can be guaranteed. Then there is running the Spire server within SGX, which gives us higher fidelity of the integrity of the server and guarantees around key material and the different operations around the exchange of that key material. There's a third proof of concept for delivering SPIFFE identities to SGX workloads under Scone. The stage of this is experimental and hasn't been quite yet upstreamed. It is work in progress. I'd love to be able to get eyes on it here with the purpose to draw attention to this work. There's exploration around native SGX attestation and how can we use the model with a potential handshake API as opposed to a workload API for agentless workloads, where we could improve the overall key security posture. There's a link here that I'll also paste in chat for an RFC around support for confidential workloads in Spire. Couple more resources that I will leave you with. There's a place I'd start off is the spiffe.io. That is the project website. We maintain a Google group for all the mailing lists. Slack is another great place if you want to jump in and learn and bring your questions. The community is there to avail themselves to support you if you want to learn about Spire or you want to implement Spire or see any possibilities to extend it to support confidential computing workloads. And obviously, well, the source code for the project is in GitHub. So with that, I wrap up and I'll pass it back to the chair.